Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Alameda International High School. In this video, we're going to be working on, still with some circles, but we're going to be talking about some chords. And if you notice, I have a nice little picture of this electric guitar, but we're talking about the chords that are inside of a circle. So notice, again, this new concept is this. So we're going to say a chord. A chord is a straight line segment, that is inside of a circle and goes from edge to edge, but not through the center. So again, notice how it goes. If our center is that point in the middle, let's say C, we would say that chord AB is still on the inside of the circle, but it is from edge to edge and not through the center. Make sure you notice some of these differences between some of each of these vocab terms. Again, that radius is from the center to the edge. A sector is talking about something like this, where it has the entire amount, it's part of a circle. The diameter is from edge to edge through the center. An arc length is that curved part. So if I would say that curved part AB, that would be an arc length, and that circumference is the entire perimeter around the circle, where the area is going to be that shaded part inside of the circle. So again, make sure you're seeing some of those different vocab terms. And also too, what I'm going to do is I'm actually going to use some of these trig functions that we have been using throughout the entire year. So what I suggest do is take a second, have that SOHCAHTOA at the top of your, I keep making that mistake, but that's okay. SOHCAHTOA. And again, those are just our simple trig ratios, so that way we can use our trig identities. And you'll see why I'm using them in just a second. So underneath of it, it has find the length of that, let's say that segment. Notice how it's a straight line, x, y. So I'm talking about this length right here. It gives us a radius of 6, and it has our arc length, our angle theta. So we'll write some things down. So I have R is going to be 6, and that angle theta is going to be 30. And what I actually have to do is this. I want to kind of draw a right triangle on the side here, and I'm going to be actually using about half of that sector that it uses, because I need to be able to find that straight line XY. And what I can do is I can make a right triangle and then multiply by 2. So this is what I'm saying. I'm saying that this length right here is 6. The angle is going to be half of theta. So I'm saying this angle here is going to be 15 degrees. And I'm looking for this amount x, which is opposite of my angle theta. Again, make sure you use those that right triangle trig. So I'm going to use, I have a right triangle. Side opposite of the right angle is the hypotenuse. Across from my angle theta is side opposite. And so that means I'm going to use sine. So it's a sine of, let's say sine of theta is going to be opposite over hypotenuse. Make sure you plug in those right values though, because I'm going to say, hey, I'm going to use this 15 degrees. And so I want to say a sine of 15 degrees is going to be equal to opposite, which is x, over hypotenuse, which is 6. And this is going to give me about this length right here, which is half of the entire amount that I need. So let's do these real carefully. So I'm going to multiply both sides by 6. The reason why I'm doing this is it will give me my variable by itself. And so I have x is going to be 6 times sine of 15. And what I could do, make sure your calculator's in degrees. And so I can say 6 sine of 15, hit enter. And so I'm going to say I'll go about 2 decimal places out, 1.55. And so what I can say now is is this my answer? Well, it's not quite, because it's saying what is this entire amount? And so let me have some decimals after that, that way it shows that it keeps going. And so what I can do is I can take this amount times 2, because I need to find that entire length xy. So I can say this line segment xy is going to be, let's say about 3.11, and we'll say centimeters. Again, the reason why I got that is because I'm saying that one of these sides of this right triangle is going to be that 1.55, and I can say that the entire segment xy is twice that, because I have 2 of those put together. So if you need to kind of draw it out for yourself, please do. I'm talking about this. I'm saying, okay, if I have my right triangle and I have another right triangle, I'm saying that each of these is 1.55, and so 2 of them together would be that amount. And then if I would say what's the perimeter of this triangle, I'd say perimeter P is going to be 6 plus 6 plus that 3.11, which is going to be about, what, 15.11 centimeters. All right. So again, make sure you take your time, have those trig identities for yourself. And so on your turn, make sure you can pause the video, but I'll help you at least draw it out. So it says, find the length of chord AB when the radius is 5 and the angle is 45 degrees. And so what I'm doing is this. I have to say, okay, if this is the chord AB, I need half of it to have my right triangle. So again, make sure you can draw that right triangle first. And so I'm saying, okay, this is going to be 5. I'm looking for this amount x, and I would say that this angle here is going to be half of 45, which is 22.5 degrees. So again, make sure you're using the same steps we did before. Pause the video and check your answer with me. All right, in example 2, towards the bottom, it says find the length of the chord ST when the radius is 9 and the angle is 32. So let's have this. So I have find the length of chord ST. So it says, let's kind of draw it out. I can have this chord, which is a straight line, ST, and it's saying the radius, which is to the center, is 9 meters. And it's saying that entire angle is 32 degrees, but I know that I need half of it, which is right here. So I need half of it, which is 16 degrees. And I'm looking for this side x. So I'm still going to use my trig function of sine. So I have sine of theta is going to be equal to opposite over hypotenuse. Plug in my values that I do know. So I have sine of 16 degrees is going to be equal to my opposite, which is x, over hypotenuse, which is 9. Set it up like before. I need to multiply both sides by 9, so I'd say x equals 9 times sine of 16, which is going to be equal to, let's type it in, let's do 9 times sine, so times sine of 16. And so it has about, 1 second here, as sine is about 2.48, some values after it. And what I'm saying is this entire segment at ST is going to be 2 times that. So I can take my answer times 2 to get my segment ST. So my segment ST is going to be about 4.96, and I would say meters. ST is going to be about 4.96 meters. So again, to repeat my steps, I drew my right triangle. Be careful not to use 32 degrees because I need to use half of it since I'm talking about the angle amount. And then I'm saying that this side length x is the side opposite of my angle. And I need to use my sine since it has opposite over hypotenuse. Plug in the values that I do know, simplify, and then I need to multiply by 2 at the very end since I have 2 of those amounts which are both x. So again, make sure you're kind of understanding that last part, y multiplying by 2 to get that entire side length of st. All right, and then in the your turn number 2, gives you a picture, and it says given that the point M is the center and MX, MB are 3. So let me do this. I'm saying MX and MB are both 3 meters, and it's saying this angle right here is going to be 79 degrees. It's asking to find that angle, that segment, that chord, BX. And again, make sure you can draw that right triangle. So it's saying, if I can draw it on the side here, I have, this is BX. I need this side length. Let me actually say, let me call it Z for right now, since that way it's a little bit easier. So I need this side length of BX, which I need to find that side Z first. And so I'm saying, okay, radius is 3. My angle is going to be half of 79. So let me do that real quick. Half of 79 is going to be, so this angle that I use is going to be 39.5. So again, make sure you're still using the same ideas as before. Plug in your values and simplify. And then lastly, it says finally, what is that length of AB? And if you notice, hey, it goes from edge to edge through the center. So again, think logically and check with me. So again, make sure you can pause that video for yourself before moving on. All right, so now on the back is actually this assignment 3-4. So make sure you're putting your name at the top for yourself. That way you can claim it as your own. All right, so it says find the length of that chord JK. So let's see, what do we have here? So I'm gonna say I have this length JK, but I need to draw a right triangle. And so I'm gonna say half of 135 is that angle amount. So I'm gonna say, all right, I have my right triangle. I have this angle here is gonna be 67.5 degrees. I can say that this side length is still 10. So I'd say this is 10 centimeters. And I'm looking for this side length X. Using my pencil a little bit too intensely. Okay. Make sure you can use your trig functions. So I can say, all right, sine of, let me move this up a little bit, sine of theta is going to be opposite over hypotenuse. That's going to be the same as sine of 67.5 is equal to opposite, which is x, over hypotenuse, which is 10. Make sure to multiply both sides by 10. So I have x is going to be equal to 10 times sine of 67.5. Make sure to type it in your calculator carefully. So 10 times sine of 67.5. Hit enter, get your values. I have about 9.23 with some values after it. But I need to say I need this entire length of JK. So I'm saying that this part right here is that 9.23, but I need 2 of them since I'm going across the entire length. So I need the segment JK. So I take my answer times 2, and I can say it's going to be about 18.48, I would say, centimeters. All right. And then in number 2, it says find the length of that chord LM. So it's talking about this side here, LM, and I need to draw my right triangle. So I have R is going to be 6. So I have, let's do it like this. I have my right triangle, and I'm saying a side opposite is X. Half of, let's do 126 divided by 2 is 63. So I have this angle length, this angle amount is 63 degrees. And I'm saying that this side length is going to be 6, which is the radius. So I can plug in my values for my variables. So I have sine Let me write my formula first. So I have sine of theta is equal to opposite over hypotenuse. That's the same as sine of 63 is equal to x over 6. Make sure you multiply both sides by 6. So I have x is equal to 6 sine of 63. So I have 6 sine of 63. Hit enter. So I get about 5.34, some values after it. And again, I need this entire length LM, so I multiply by 2. So I'd say it's about 10.69 centimeters. Is that chord LM? Again, make sure you're seeing how I got this. I'm saying that from here to the center is x. That means I have that same length again, which is why I'm multiplying by 2. All right, towards the bottom in number 3, it says triangle POQ. So POQ is a sector of a circle. The measure of angle POQ is 75 degrees, and the chord PQ has a length of 8. I need to find the radius of that circle. So let's again have our SOHCAHTOA just in case. So I have SOHCAHTOA. And let's kind of figure out how I can do this. Well, I'm looking for the radius, and it gives me that line segment. So I can say, all right, let's do this. I'm gonna make my right triangle like this. I can say, all right, I have my right triangle. I said that I know I'm looking for this side length x, and I know the angle amount is half of 75, so 75 divided by 2. So I have 37.5. All right, and half of 8, so this amount here is going to be 4. And so I'm still going to use sine, but what I can do now is I have to do those 2 steps to find and solve for x. So I'm going to say, all right, sine of theta, opposite over hypotenuse. And this time, we're saying that we're, solving for the hypotenuse, which is the radius. So I'm going to have, let's say, sine of 37.5. Again, make sure you see where I got that's at 37.5 because I'm taking half of that angle. And so I have opposite, which is 4, over hypotenuse, which is x. Again, the way this works, use your inverse operation. So I'm multiplying both sides by x. So I have multiply both sides by x, and then divide both sides by sine of 37.5. Sine 37.5. So what I have is this. I have x is going to be equal to 4 over the sine of 37.5, and that will give me my radius. So I have 4 divided by sine of 37.5. It's giving me my radius, so I'm going to say my radius x is going to be about 6.57 centimeters. And the way I found that is still the same steps, except now our x is in the denominator, so make sure you're seeing those inverse operations that I do. And then it says, for number 4, it says using the same circle as number 3, find the major arc length of PQ. Okay, so what is it saying? It's saying find the same, using the same circle, so I have the same circle. From number 3, find the major arc length. So that means it's the larger of the two. So it's not talking about the smaller length PQ right here. It's talking about this outside. Let me see if I actually have better color. So let me actually use red for this one. So it's talking about the major arc length, which is that outside amount in red. Okay, so how do we find that? Well, a couple simple things. We know, let's get our labels down. So we said we found our radius. So we said our radius r is going to be 6.57. We said our angle theta, we need to take 360. So we do angle theta is going to be 360 minus 75 to get this major arc right here. So we do 360 minus 75. And so we're gonna say it's gonna be about 285. So let me read that a little bit more carefully. 285 degrees. All right. So I have the two things I need, and so let's have our formula. So I have my arc length PQ. So PQ, that arc length, again, that's that curved part, is gonna be as follows. It has, let's have our angle amount, which is 285 over 360. And then we have times 2 times pi times our radius, which is that 6.57. Make sure you plug in your values exactly as they look. So I have 285 divided by 360. I have times 2 times pi, try that again, times pi times that 6.57, which is our radius. Make sure I'm still, there we go. Hit enter, get our value. So I'm saying this arc length of PQ, so this arc length PQ, notice how it's curved, is gonna be about 32.68 centimeters. Can make sure you can ask questions for yourself, be able to see how this is set up, and as always, super slam that subscribe button.